Hi everyone. So after taking all of those tests today, my question for you is, think about that very first test from Mensa. Did those 30 questions measure your ability to learn from experience, solve problems, and use our knowledge to adapt to new situations? Consider what was measured. Consider the tasks you had to do. Does it fit with with this definition of intelligence? If you have another 30 minutes in your life, I challenge you to take that emotional intelligence test, the link that I put up on the Moodle site, just so you can gauge another area that's tested. And I guess the big question to consider here is we discussed in class yesterday about what is intelligence anyway and what influences it. And psychologists are very adamant that intelligence is not a thing like a trait. It is a socially constructed concept. So each culture would deem intelligent whatever attributes enable success in that culture. So in our culture, what attributes enable success? That's the great question. But with all of this criticism, the other piece that we have to continue to keep in mind is if we keep trying to stretch this concept of intelligence to include everything we prize, then intelligence will lose its meaning. What is it anyway? If we keep creating new forms of intelligence, if we talk about particular or specific areas of intelligence, then did we lose that entire concept of intelligence? And then we have this link between intelligence and creativity. Remember, creativity is the ability to produce ideas that are both novel and valuable. Novel here meaning new, fresh, interesting. And there is somewhat of a correlation with intelligence. Here are the key elements of creativity, and we discuss these in the cognitive unit. If we actually distinguish between people who are successful, in many ways you could say that these successful people, they might not necessarily be members of Mensa. They might actually have an incredible capacity for creativity. A Nobel Prize winner, physicist Richard Feynman, he said that after he got his Nobel Prize, he actually looked back on his life and he looked at his high school record and he realized that his grades weren't as good as he remembered, and his IQ was good. He said his IQ was 124. That's certainly above average, but it wasn't exceptional. It wasn't incredible, amazing, yet he was able to win a Nobel Prize in physics. So intelligence is certainly part of it, particularly with this number one component of expertise, but there's a whole lot more going on. Do you ever wonder if people with bigger brains are smarter? Well, there is some correlation between brain size and intelligence. Lord Byron, famous English poet, apparently his brain was 5 pounds, not the normal 3 pounds. Beethoven's brain was found to have numerous and very deep convolutions. Einstein donated his brain to scientific research, and there is an extensive study being done on his brain today. What's interesting is the whole size of his brain wasn't any different than a typical person's brain, but his parietal lobe's lower region was 15% larger than the average brain, and this just happens to be a center for processing mathematical and spatial information. And other areas of his brain were actually smaller. And by the way, Einstein was, people say that Einstein was slower to talk. I believe he didn't even start speaking until he was the age of 4. Then we have the question of speed. Is speed connected with intelligence? Well, it shows that there is a correlation. People who score high on intelligence tests perceive stimuli faster. So you could argue that they have faster response time. So what happened in this study was a stimulus, this image, was flashed, and then immediately it was overridden by this image, this masking image. And the participants were asked whether the long side appeared on the right or the left, and then the time that it took them to answer was measured. We're talking here about a difference between 1/100th of a second and 2/100ths of a second. But this study did show that those who perceive very quickly tend to also score somewhat higher on intelligence tests. So the next question, if we could actually define intelligence, then the next question is how do we actually assess it? How do we assign intelligence some kind of number or data point? Well, it all started with Alfred Binet. So back in 1904, in France, the Minister of Public Education commissioned Alfred Binet and others to study this concept of intelligence and achievement in school. I think what's important here is his presiding assumption. We talked about this in class. Binet and his collaborator, Theodore Simon, assumed that all children follow the same course of intellectual development, but some develop more rapidly. So their assumption is everybody will develop. There's the same maybe movement, but some children develop more quickly than others. So that assumption moved him towards creating this concept of a mental age, what a person of a particular age should know. And they discovered that that mental age can be a predictor of future performance, and therefore in the public school system, developing some sort of number or mental age will then allow them to service students who are struggling in school better. It should be important to note here that he was very, very adamant that this age, this number that he's created, should not be considered a fixed quantity. He said intelligence is not a fixed quantity, and we must protest and act against this kind of brutal pessimism. So he's saying that a person's intelligence can change depending on the environment and the situation around them. And his greatest fear was that this would be used to label children and limit their opportunities. This is interesting because one could argue that today that is how it is used. So Binet and Simon came up with the concept of mental age. Then we have Lewis Terman, who came up with a test, the Stanford Binet test, which is an adaptation of Binet's test to use to measure American children in American schools. And then we have William Stern, who came up with this concept of IQ, intelligence quotient. So you take the mental age of an individual divided by their chronological age, their real age, times 100 to get that IQ. So here's that formula. Remember who actually William Stern came up with and Terman used and developed the new IQ test. Let's look at this example. We have an 8-year-old with a mental age of 10. What is her IQ? So you take the mental age 10 divided by the chronological age, and you get the IQ. A 12-year-old has the mental age of 9. What is his IQ? So you take that mental age 9 divided by 12 times 100, and you get this IQ. Finally, a boy has a mental age of 10 and an IQ of 200. How old is this person? Take a look at that bell curve that I gave you yesterday. How likely is it for somebody to have an IQ of 200? Well, the IQ formula works fine for children, but there's some big problems with adults. Consider this. You've got a 60-year-old man and does as well as a 30-year-old. Then his IQ would be 50. That's not very smart. Now we have two key vocabulary words when we're dealing with testing. We have aptitude tests and we have achievement tests. An aptitude test is supposed to predict your ability to learn something new. And an achievement test is designed to reflect what you know. So we would put the IQ test under the aptitude category, and we would put the SAT or the ACT in that area. Achievement test would be like the AP Psych exam that you're going to take in a month. That test is reflecting what you've learned, or any content area test that you take in school. Now this graph is showing you the correlation between SAT scores and IQ. There's a very strong correlation, actually 0.82 correlation. One interesting thing to remember, though the SAT or the ACT is considered an aptitude test, so it's used to predict your ability to learn, it is supposed to predict your success in college. data shows that it's actually not as good at predicting future college success as simply your GPA or your class rank. So these clear-cut definitions make it seem like these kinds of tests are very distinct, but if you really think about them, it's not so clear-cut. If you think about your achieved vocabulary, so the amount of words that you know and understand, this is definitely going to influence your score on an aptitude test, which is designed to predict your ability to learn. And your aptitudes for learning, so your ability to learn a new skill and your ability to take tests, will definitely influence your score on any achievement test in school. Now the WAIS and the WISC are the newest, maybe more common forms of intelligence tests that are used today, developed by David Wechsler. And this is the most widely used intelligence test today. So this test has 11 subtests that are broken into verbal and performance areas. So when a person gets a score on this test, they get an overall intelligence score, just like the Stanford Binet, but there's also separate scores for verbal comprehension, perceptual organization, working memory, and processing speed. The use of this test today is generally used to screen people that might have some kind of reading or language disability. So they might have average or strong scores in some areas and then a low verbal score or a low comprehension score that identifies them as needing some kind of special services dealing with some kind of specific ability. Now, all of this works fine if we can trust the results of a test. We have to be able to actually trust it. We have to believe that the test is worthwhile. The test is saying what it says it is to say. So we have three major criteria. The test has to be standardized, it has to be reliable, and it has to be valid. Standardization, this is next week, juniors, when you're taking that MCA, the directions that are read to you from a script, that is a requirement in order for that test to be standardized. When you're taking the ACT, there are very, very specific guidelines that need to be followed, and that is for standardization. So here's the normal curve. This should look familiar to you. And if we think about, this is the Wechsler, but if you think about an intelligence score, the middle number would be 100, and we've got 68% of the population whose intelligence score ranges from 85 to 115. And the top 2% of the population would be higher than 130. Now here's what's difficult about these intelligence tests. In the past 60 years, intelligence scores have risen steadily, in fact by an average of 27 points. So you wouldn't notice this because the actual score continues to be re-standardized, okay? So if you score a 100 on an intelligence test today, and your parents scored a 100 on an intelligence test 30 years ago, the actual score on that test would vary. In fact, your parents would have answered less questions correct than you today. So the average person's intelligence test score 80 years ago was, if we look at today's standard, was only a 76. And this is not just here in the United States. This has been observed in 20 countries, from Canada to rural Australia. And this would be considered a very important phenomenon. Why is this happening? Flint's research has caused many people to question whether intelligence tests actually measure intelligence. What do they measure? Flynn would argue that intelligence tests actually measure problem-solving skills, which weakly correlate to intelligence. And next we have reliability. This should be review for you. If it's reliable, it has consistent results. And reliability is different from validity. Is it measuring what it's supposed to measure? Flynn would argue no, an intelligence test does not measure intelligence, it measures something else. So we have content validity and predictive validity. And that is the end of this video. See you tomorrow.